we have my Microbit multiplayer Tetris setup. In its current configuration, this would be the centralized setup, with these two boards being controller boards with very little running on them, only controlling movement. So you see when this game starts, when you hit the left button, it moves on that screen. And the same for here, move it either way. Now, this board initializes the game. As we can see, when we reset this one, nothing happens. Reset this one, it begins dropping, and it transmits over the X position when it's at Y4 and it's not a full column to this board, and this board starts displaying that X position. When the game ends, when there is a place tile at this top row here, it displays a sad face and the score. Each row cleared is worth 40 points, and each board tracks its individual score up until the very end, where they tell each other their score and add them up, and this board sends over the score to both the controllers. So once this finishes, for clearing a row, it is a bit buggy. I'm not exactly sure why it doesn't work. When I can get it to there is a few bugs. There we go, we cleared the row. You can see that it moved all of the other rows down from above it. Now, I ended up removing the L-shaped piece as it was causing too many errors and I was unable to fix it. But I have expanded the straight piece to be 3 high, which we can see here, and the square is still a 2x2. Now, for the setup for the decentralized version, I won't change the code, but there's no controllers, and the boards themselves act as controllers for their section of the board. So, say this piece would control the movement for any bricks that are falling on its side, and this would control the movement for any of the pieces on its side. It's a peer-to-peer connection and would be decentralized in that option. For these, for the centralized, these two are directly connected, and then each board is connected to both of them. The radio.
Okay. Here are the code for all 5 different boards. The secondary main, the difference between the distributed versions and the centralized versions are just that this controller board controls the movement. So if we come here and look at the main centralized and go up to the radio received, we come here, we see the on receive string of button A or button B. It will call the move right or left respectively, and the button A and B radio signals come from the controller. When the button A or B is pressed on the controller, it will send that radio signal. So the difference that makes on or the difference in architecture is that for the distributed version, it is just straight peer-to-peer connection between, say, the main and the main and the secondary board. Now, on the centralized, that connection is still there. However, instead of being on the front end, because on the distributed, each board is also the controller for its own section of the board. It will control the movement left and right. On the centralized, the game boards don't control the movement at all. Or the controller board does. So while the game boards will still run most of the same code, instead of being on the front end or on the edge of this system, it's pushed to the back as the controllers then become the new front end or edge of the system, leading it to be a more centralized system. Now, back onto the code, go back to this secondary board. As you can see, I put a lot of things onto the functions just to make things a bit easier, as I need to call things a couple times and it stops me from having to rewrite it the same. Makes everything consistent. Now, for the display all, that just resets what the display draws the images, draws the pixels, and will also, for the secondary board, it will check columns that are full. So we can see here, when a column is at the top and it's not already full, as the secondary board will keep track of full columns, then it tells the main board that that column is full. Now, on the main board, instead of tracking full columns on that, it tracks whether or not the game is over, as when a place tile is placed at Y0, that means the game is over, as it is at the top of the board. So it will, if that's true, then it will let all the other boards know that the game is over. Now, for placement, staying on the main board, we have a few checks being done, seeing if the brick is about to collide, or if it is at Y4. If it is, then it continues on with a few more checks, and just double checking, making sure things don't randomly get placed. So here, we're checking if the board is directly above if the brick is directly above a section of the brick or a tile, as we see here, is directly above a place tile, as we're checking to see if the same X position of the brick and the Y position shifted down one, if that combination or position is in place tiles, basically saying, effectively checking if the floating brick, or the brick that's moving down, is about to move into a place brick. If it is, then this check will become true. This is basically the placement of it. It just combines the two arrays of the brick array and the place tiles array to become the place tiles array. Resets this variable, and then it chooses a new brick and updates that brick's position. I do that again here because if we play the simulation, see when it's going down here, may be able to move it, or when it goes across, it may place up here, and you'll want it to place up there. So that's why this check is done a second time, and also just for consistency, in case something weird happens. Same things are done. However, this is also where that the transmission of the X value is done. It checks if the Y is at 4, and then it updates the brick position, which is how it smoothly appears if it's looking down when you combine that being updated with the Y position being increased. It also does, this check is for the buffer, which makes sure all of the X values are transmitted correctly. Redraws the screen, and this sends the X values that are contained within the buffer. Now, this function just resets everything when the game is lost. When the secondary board transmits the tile placed over the radio, then this part here, just it picks a new brick, updates the brick position to that new position, and redraws the board. Looked at this already. Column empty, basically, when the secondary board clears that top line, so this line up here, it tells the main board that, and the main board will clear out all the full columns. Currently, I'm experimenting with having, instead of having the full column command, array, I am just placing a tile at Y5, which seems to be working just as well, if not better. However, that tile at Y5 will never be seen as a user, as there is no LEDs at that. Now, here is where it stores the full columns. We can see what I was just saying there. It puts the playstyle position at Y5. It also adds the position to the full column, just for the check, a few checks that are done. And yeah, just leftover of what was done before. So this is the new code. That was the previous code when I was using the full column array. Now initializing everything. Then we have the brick class. This is the same across all 4 of the main and secondary boards. Getting initializing X and Y. Then we have the choose brick function. Currently I only have 2 different bricks, as the L-shaped brick just wasn't doing what it should. I was not able to find out why, so took this route. Just here, this is just to randomly select one of these based upon the length of this array. So when you add more, if you were to add more bricks, you wouldn't have to adjust this random selection. Then if it's a square, since I'm using the this.x, basing it off of 1, which you can see here, this is for the brick positions. I base it off of 1 position, then add on to that. If I were to allow this to be picked from 0 to 4, say 0, 1, 2, 3, and 4, if it were to start at 4, since I have the master like X position or whatever being on the left side, that would mean that technically the X position would, or the other half of the brick would be X of 5, and that can't be displayed. So I limit it to be at X3, which displays the full brick. The Y, I don't have to do this with the Y, as I have the main Y up at the top, so it builds down under it, which is ultimately why I had to have multiple boards, as it was almost impossible otherwise to be able to easily play it, as you'd almost instantly lose as soon as it started. Moving, this is variables: move left, move right. Just a few checks to make sure you're not moving into something, you're not at the edge of the game board. And if that all works out, then it just moves you left or right, updates the position. This is the main game loop. You've got a fall timer and move timer for the falling of the block and moving left and right, just to make sure, just to stop it from moving super fast. So it's actual, so you can process what's going on. Here checks if the brick is about to collide with a place tile. Then here is the line clearing. There is the secondary board does check the top line, as it wouldn't be game over if it was at the top line on the secondary board. Now it just adds the sum of all the X positions plus 1, which if there were place tiles in all slots in the row, or all columns of the row, then the sum of that would be 15. It's just adds some. It just makes sure that all of the columns actually are filled up on that row. So columns or rows aren't cleared when they're not actually full. So you can see does that. This is also scoring. Each cleared row is worth 40. You see that it'll remove the place tile one by one, and it will then move all of the other place tiles that are above it down by 1. It does that for all the other rows as well. And if the game is over, it runs this, it shows the sad face, then it tells the other board what its score was, and the other board will tell this board what its score was. Then up above in the radio receive section, it will combine the two scores. Then here it displays the score. Also, it'll send the score over to the controller, and then it will, all 4 boards will show the score. Now, yes, the code for all of them is almost the same, almost exactly the same. There are a few things like checking for game over or checking for full rows, which are only done on one or the other. Yeah. So, while security for Tetris isn't that high of an importance, I do make sure that radio signals are only accepted if they come from the serial numbers of the boards, just to reduce the chance of tampering with the information. It's still possible, it is reduced. Now, for scalability, if it were to be able to, say, have a larger board, it would most likely be put onto one board instead, which, so one board, and then like as many controllers as you want, like 2, 3, 4. Now, one board would make it a lot faster, a lot easier to deal with, and it would also open up the opportunity to, say, to have another like main board with its own controllers and that, which could open up the opportunity to have a team-based multiplayer. So it'd say, let's be team 1, team 2, and they could compete against each other, and you could, say, have another board in the back end keeping track of the variables from both of these, making sure that they're not being tampered with, and to keep track of the game state and the score and see who wins. Ultimately, storage would likely still be done on the main game boards themselves, as there is not much to be stored. There's not a lot needed to run Tetris, but you could also have, say, as I was saying, storage on another microbit, storage of the variables and that, and the game state and all that, and just have the processing of the active game done on the game boards instead of everything being done on the game boards, distributed a little bit more, which might allow you to have even more teams, say like 3 or 4 or something. Could be interesting, but it just better hardware opens up a lot more opportunities and ways you could go about doing multiplayer Tetris. And it would also enable the screen to be a lot larger, which is a major downside of the Microbits, and is the source of many of my problems I've been facing. Yeah.